Yeah, it's been a while since we've done a test. So this has been a sort of a slow, steady unit through chapter 8 and 9. So just as far as the test goes, to clarify for you, the test will be on Tuesday next week. So that's going to be the 2nd of September during lesson 1 and 2. So it's a week from today. It'll go for about 55 minutes. And at this stage, it's 41 marks, although that is subject to change. Just go through our skills here. We've got chapter 8 and chapter 9. Now, chapter 8 is largely a recap from year 11. There's lots of skills in year 11 there with a few new ones. And then chapter 9 is all new skills where we have things like the central limit theorem and confidence intervals. So here's a bit of a skills checklist for you to go through to check off, yes, I know how to do all of that. So these are the skills that we're going to assess in the test. And then we've got those revision resources, all the tests up the back, thanks to those that have grabbed them already. Okay, so what we'll do with our comprehensive review is we're going to go through these questions together. So we have, firstly, consider the probability density function, ax squared, which is valid from 0 to 1. Part A says find A. So if we have the function f of x is ax squared, that's our probability density function, and we know it's valid from 0 to 1, what it means is the integral from 0 to 1 of ax squared is equal to 1. That the area under the curve is equal to 1, and here we're going to solve this for a. So straight away what I'm going to do, I'm going to pull a out the front, and so we're performing this. Integral of x squared is x to the 3 on 3. Sub in our upper and lower boundaries. And so we have a times a third equals 1, and so we have a is 3. Okay, part B says find the mean, median, mode, and standard deviation. Now in the tests, historically, this has sort of been question 1, and you get 4 marks here, really just for typing in all of these things into our calculator. So for the mean is the integral from a to b of x times f of x, times 3x squared. Okay, so that's going to be our mean. We'll type that in a moment. Our median is going to be the integral from 0 to m of our function such that the area is 0.5. And this is going to give us a value of m, all right, such that half the area exists to the right and half the area exists to the left. The mode is going to be the event with the highest probability. Now I'll just talk about this graph that we'll see in a moment. It's 3x squared, so from 0 to 1, it looks like this. Okay, that's what the graph looks like. So that means our mode is the event with the highest probability. Our mode is going to be 1. Our median is going to occur here somewhere, such that this is 0.5 and this is also 0.5, right? It splits it in half, and we've got our mean there as well. So we calculate both of those, and then the standard deviation formula. I've got so the extra sheet attached to you is a summary of the skills. We've got formula for standard deviation here as well, which is the square root of the integral from 0 to 1 of x squared times our function. X squared times our function. With regards to x, take our mean squared. So we'll have to evaluate the mean and sub it into there. Okay, so let's evaluate these things. So for our mean, we have x, 3x to the 3 from 0 to 1. And I've got 3 on 4, or 0.75. All right, for our median, we'll do a solve m. We're solving this equation. So option integral, make sure we know how to type that into our calculator. We've been doing it a bit with our folio, so it should be pretty fresh. From 0 to x, and we want it to equal 0.5. We're solving for x, and we can restrict the boundary as well, which will make our calculator do it faster. Okay, so we can restrict the boundary from 0 to 1, because we want it to occur in that interval somewhere. more solutions, and we've got 0.7937. So 3 significant figures, 0.794. Okay, and then for the standard deviation, well, our mean was 3 on top of 4 squared, so we'll type that one in. So option count the integral of x squared times 3x squared from 0 to 1. That take 3 on 4 squared and then square rooted. And we've got root 15 on 20. Okay, so 4 marks there just for typing some stuff into our calculator. So remember, in a test, there's easy marks to get, there's hard marks to get. Make sure you get the easy marks. Okay, so that's question 1. Let's have a look at question 2. We have the weight of eggs is normally distributed with a mean of 80 and a standard deviation of 12 grams. Find the probability of x, the variable x, so the weight of x being larger than 65 grams. So this will be an NCD calculation. Our lower boundary is 65, boundary is infinity. And our standard deviation is 12 and our mean is 80. Those are some jumbo eggs.
0.25.
Thank you. 0.25. 38, which is 0.254. Very good. Okay, determine the probability that an egg weighs less than 60. Okay, so this is the probability from minus infinity all the way up to 60. All right, standard deviation and the mean remain the same.
0.7257.
7257 to 6. Very good. Part C, an egg is considered a jumbo egg. Sorry?
On part A, it says interpret.
Interpret. Okay, good, cool. This is the probability that a randomly selected egg weighs more than 65 grams. Although, did you type in 80 or 60?
80.
From 65 to infinity?
Yeah.
Yeah, it should be larger than that.
Okay.
I'm just looking at
For the. Oh, hang on, I had the wrong way.
0.894.
Yeah.
Yeah, that sounds better. And then that one should be a little bit, should be a bit smaller actually. So we'll just fix both of those. Anyway, this is the probability that a randomly selected egg squeeze it in. Right, yeah. Weighs more than 65. So don't do what I just did and like skip the interpreting part because that's worth 1 mark. Okay, so read the question carefully. We say RTFQ, that means read the full question. So all right, anyone got an answer for
0.078.
0.0? Sorry, I'm really deaf.
478.
478. I'm really deaf or you're mumbling. All right, so that's part B. Okay, so we're ready for C. An egg is jumbo if it's in the largest 10% of eggs. So what is the smallest weight a jumbo egg can have? So if it helps, and it helps me, draw the distribution. So here's the distribution of eggs, and we're saying an egg is considered jumbo if it's in the largest 10%. So the largest 10% is going to be here, and our question is, what is the smallest weight? So that's going to be this value of K here. What is the smallest weight that a jumbo egg can have? So this is going to be an inverse normal calculation. Our tail is pointing to the right. Area is 10%. Our standard deviation is 12 and our mean is 80. Just going to type all that in. Right, 0.112, 80. Well, I've got 95.37, so 95.4. Alright, so if an egg weighs 95.4 grams or more, it's considered a jumbo egg. Okay, there are 12 eggs in a carton. Let S12 be the distribution that arises from the sum of 12 observations. Is S12 approximately normal? Justify your answer. Okay, so we're going to say, we're going to look at the distribution of X first, and we see that X is normal, therefore Sn is normal for all values of n. So we're going to say, yes, S12 is normal, because X is normal, Sn is normal for all n. Alright.
What does that say? X is normal, Sn is.
Because X is normal, Sn is normal for all n. For all values of n. Okay, so that's part D. On to part E. What is the probability that a carton 4 eggs will weigh more than 1 kilogram? So this is, what's the probability of S12 being larger than 1,000 grams? Okay, so we've got to consider the unit conversion. Those will pop up, they'll sort of just sneak in there. And so what we're going to do is we're going to say, well, it's an NCD calculation. Our lower boundary is 1,000, our upper boundary is infinity. And then we need the mean and the standard deviation of the variable S12. So the standard deviation of S12 is going to be the standard deviation of X times the square root of n. Okay, 12 root 12. And the mean of S12 is going to be the mean of X, which is 80, times the number of trials, the mean times n. So both of those are from exercise 9b, that formula for developing the mean and standard deviation of Sn. Okay, so let's type that in. So from 1,000 to infinity. 12 root 12. And we have 80 times 12. We've got 0.1679, 0.168. So that is part E. Part F, one massive egg. It's a massive egg. It weighs 120 grams. How many standard deviations is it above the mean? So this is a z-score. Remember, a z-score is a measure of how far a result lies from the mean. Negative z-scores mean it lies below the mean. Positive z-scores mean it lies above the mean. So in this circumstance, we have 120, take 80, divided by 12. So 40 on 12, it will be 3.3 recurring. Alright, so this massive egg is 3.3 standard deviations above the mean because we have a positive z-score value. Tremendous work. Okay, a sample of 150 people finds 96 of them have brown hair. Calculate the 96% confidence interval for the true proportion of people with brown hair. Alright, so we won't do this one manually, we'll just go straight to our calculator. And so we're in statistic mode, we go interval, z, and it's a proportion. Okay, we're not asked a sample mean, we're asked a proportion. And we are asked for 96 is our confidence level. We have 96 successes as well, and 150 people. So we type that in, and we've got the true proportion is between 0.5595 and 0.7205. Now I'm going to leave it to 4 figures for now, just because if we round that and round that, so it's just going to carry on. We won't have too much of an effect, but we'll just leave it for 4. Okay, so that's part A done. Alright, SEG claims that at least 80% of people have brown hair. Is his claim correct? Justify your answer. Okay, his claim lies completely above the confidence interval, so the confidence interval does not support his claim. So we're going to say no. His claim lies completely above the confidence interval. Very good. So his confidence interval does not support his claim. Okay, Matthew claims that definitely less than 80% of people have brown hair. Is his claim correct? Okay, so the confidence interval supports his claim, all right, but I'm being intentionally tricky here because I'm trying to iron out a point. All right, confidence intervals never guarantee an outcome, they only indicate an outcome. So, the confidence interval supports his claim, supports, what's his name? This guy, Matthew's claim. But confidence intervals never guarantee. They are only an indication. Very good. We can't say it's definitely less than 80%, but we can say we've got good evidence to suppose it is less than 80% based on the confidence interval. Okay, Jill claims that most people have brown hair. Is her claim correct? So there's something like a little bit ambiguous here. What does it mean by most people? It would mean more than 50%, more than half. And the confidence interval supports Jill's claim because the confidence interval is completely above 50%. Yes, the confidence interval supports Jill's claim. It's a bit like the most people think they're better than the average. All right, a sample of 200 people who don't use water softeners finds that 100 of them have brown hair. Okay, calculate the 96% confidence interval. All right, so we'll do that first and then we'll assess the question. So we have 100 out of 200 for a 96% confidence interval. And the confidence interval that we get, so this is part E. I'm going to write it up here because we're going to be comparing them in a moment. 0.427, 0.4274, less than P, less than 0.5726. Okay, there we go. So that's first part of it is calculate the confidence interval. Okay, the question is there sufficient evidence to claim those who don't use a water softener are less likely to have brown hair? Okay, so a sample of 200 people who don't use water softeners found that 100 of them have brown hair. Is there sufficient evidence to claim that those who don't use a water softener are less likely to have brown hair? The answer is going to be no, because these confidence intervals overlap. Now I might illustrate this for you. So if we draw the first confidence interval, it's from 0.427 to 0.576. And what this is the proportion of people who don't use a water softener but have brown hair, 0.74. And this is the proportion of people that have brown hair. 0.5555 to 0.7205. So because they overlap, it suggests that the true proportion could still lie in both confidence intervals, which means there's not sufficient evidence to suggest there's a difference. Only if they are completely separate, like this, and they don't overlap, can we suggest, does the evidence suggest that there's a difference, okay? So the way we'll answer this is we'll say, just make sure we answer what the question says. Is there sufficient evidence to claim they're less likely to have brown hair? No. The confidence intervals overlap, which means the true proportion can lie within both, so that evidence doesn't support the claim of any difference. Very good. Okay, so we're sort of really ironing out confidence intervals here and how to correctly articulate answers to them. Remember, it's never definite. It's always about what does the confidence interval support and what does it not support. Does the evidence support it or not? Really good. So that's our test summary. We've covered a lot of skills there. Just having a look at the second sheet I've attached. These are all important formulas that can probably go on your cheat sheet. I'd have a read through of those, make sure we understand them.